Hi everyone, good to see you there. This is our new unit. In this unit, we talk about algorithms. So, in algorithms, we have some part of topics that I can tell you. This subtopic of the algorithms. The first one is the building algorithms, and after that, for the second one, it will be evaluating algorithms. Then we continue with the solving hard problems, and fourth will be parallel and distributed computing. So I can say for first two steps will be so easy, and three and four a little bit difficult, but no worry, you will just handle that. Okay, already we using in our daily life, and nothing to worry about it in it. Okay. So, what we're gonna do, let's get started with the building algorithms. By the way, that's all video or all information come to me from Khan Academy that I'm just bringing information to explain you how you can handle things. Already things there, and the teachers answering like child's questions or younger guys' questions, but I just want to show you in a practice that you can understand better than reading. Okay. So just you can make practice after read and after write everything. Let's get started. So building algorithms. What it's saying us. Building algorithms. So we're reading our programs, we calling our programs, but we didn't know like how to do it, right? So for the first, we already know how to do it. So if you talk about if, else, for, while, and even the others, all of them works in the algorithms logic. So when you say if something like that, do these things, do instruction. If not, do another things, which is we calling else. So we have there, for example, what selection algorithms. And if you're reading directly below to below, that it will be sequencing algorithms. I know it just mixing your mind, but no worry. When you use for loops, for example, it will be iteration algorithms. All right, let's get started. An algorithm is a step by step process that describes how to solve a problem in a way that always gives a correct answer. When there are multiple algorithms for a particular problem, and there are often are. So the best algorithm is typically the one that solves it the fastest. So that's important. The algorithms are helping us to find best solution, fast solution, okay? Everybody can write their algorithms, but some of them so fast algorithmically and logically, okay? So as computer programmers, we are constantly using algorithms, whether it's an existing algorithm for a common problem, like sorting an array. I know you're already knowing about it, maybe. So if not, you can just check sorting and array algorithms, or it is a completely new algorithm unique to our program. So by understanding algorithms, we can make better decisions about which existing algorithms to use and learn how to make new algorithms that are correct and efficient. All right, cool information, thank you. An algorithm is made up of three basic building blocks. What it is: sequencing, selection, and iteration. It is in general. This one is for loops, okay? Loops. This one representing loops. Selection representing conditionals. You can say conditionals. And the first one, sequencing, is already the sequencing that you reading codes below to below in the same desk. All right. But when you use if else or else if or something like that, so you're using selection algorithms. But when you use loops, for example, for loop, while loop, and the other loops, do while loop, or even switch loop, so this kind of stuff, it will be iteration algorithms. Okay, let's get started with the sequencing. I hope you understand. So, an algorithm is a step by step process, and the order of those steps are crucial to ensuring the correctness of an algorithm. Okay, we need to verify also our algorithms, right? So, here's an algorithm for translating a word into Pig Latin, like from pig to IG. Then we have here this one and pay. Pi. So, now what we are going to do, we just sorry, we just removing after some operation this p, and it's just staying like each pi like that. Okay, so what's going on here? So just like from peak to ip, this one happened, this one. So now we have pig. All right, let me write here. So let's say we have pig, and it says append this one. All right, I already add here, right? Then it's saying what? Append first ladder. All right, what do you think about our first ladder? First, we need to store that, right? So just think that we said first ladder in JavaScript, like word first ladder or const or whatever else. Just you can say, let's say p like that, okay? Then we can just say p here, and after that we just combining all of them in the steps. Append first ladder, that we can say it is firstly like append this one, the things going like that in here. And after that, we're saying append first ladder. Append first ladder where? Let's say this one is for our cent, let's say like that. And this is pig. Okay. So now when we try to make it like our send dot, let's say push in JavaScript, what it will does, so it will, let's say first ladder. So in this case, it will be peak, then what? What do you think? So it will be peak, this one, and again P, right? Amazing. You're doing a great job. Then append I. So A, we can say like that. So let's say our sent and our second ladder, let's say war second ladder like that, and we can just say for that I like that, and we can just come back here. Sorry, so we can say new one like that. By the way, I just don't want to write war each time, but anyway, war new one, let's say new one like that, all right. So then we can say new one dot push what? Right now we're gonna put second ladder, right? Second ladder. So I just showing you in lazy way, okay? Just be sure what we are doing. That's it. Nothing more. All right, we already added it. So added that. If there is some spelling issues, I'm sorry for that. I'm not sure like where is that. All right, now what we have peak pay. This one, right? Now, the last step will be we gonna remove this P. How can we do that? What do you think about it? How can we do it? Do you have some idea that we can do it? Hmm? Can you think about it? So we already added first ladder in here, and now we need to remove that. How can we remove? Check here, here, where? How you can do that? Do you think it is something easier? Can you do something like that where total, where let's say total sentence like that, and let's say new one, and can you slice it? What do you think? No. Can you remove it from there? Oh, you remember something that we use firstly in our programs, something else that for the removing particularly like some point that we want. Let's go to the displays. So as we did something in here, and if you want to remove something, what we did, or you remember? Yeah, splice. So do you think we can use splice in here so that we can say we want to remove, for example, something else there. When we use one to the first part, it's just removing, right? You remember? All right. So what will happen? What do you think about it? So how we can remove that? Oh, it's saying so I can remove that item at index 2. Index 2. Yeah, so we're using this one, right? Index 2, 0, 1, 2. It is write this article, right? In this case, that we want to remove it into not list. It is string that we can think like that, right? So okay, let's go to the other side. Go back there, little fast. Okay. Do you think we can apply here something like that? Like that, for example, mm, this one that we will get it. We'll put in here and we'll say splice. And after that, we will choose the point of the ladder. Do you think it works? Can you do it? Just think about it. This is really important that you can do something, but how you can. What do you think? Can we use their if else method to fix this? Conditional, sorry. All right. This is big question for you. Do you think we can make it like 0, 1, 2, 3, and fourth index? It is fourth index that we want to remove fourth index with that method. Do you think it works? Then it will come like a pit pay like that. Sorry, it pay, I pay like that. Do you think it works? Not sure? All right, this is good question for you. Do it later. Selection. Algorithms can use selection to determine a different set of steps to execute based on a Boolean expression. Look, again, in here, we use everything in the selection method. One, two, three, four. There is no if, no loop, right? Not for, nothing conditional, or nothing like that. It is just sequential, like one, two, three, do stuff next to next. Now they're the same, but so this is something that you need to know concept. Here's improved algorithm for Pig Latin that handles words that starts with vowels so that X becomes XI instead of the unpronounceable GGC S E A I E A Y. Sorry. In here we're doing append. First we adding append. Then what we doing? We're just saying store first ladder again, and after that we're saying yai. So what I'm talking about, we're talking about here, yeah. Then we're saying append yai. Otherwise, it is else conditionals. Append first ladder. So okay. Then we're saying append I. It makes it again yai, AI, this one. Remove first ladder, and it becomes this one. E is just removing from here, and GGS staying here, EAI also staying there. But as you know, it was YI, but right now it is GGS. Or do you think we just appropriate it with some way? So append this one, okay. Store first ladder, okay. First ladder was E, right? We've stored it in here. We're making like that. So this one will be in here. And if first ladder is vowel, yeah, this is vowel. So then append I. Yeah, we did like that. Perfect. It works directly. In other way, it's saying else append first ladder. Okay, append first ladder E. Then append I. It is already in here, and remove first ladder. Yeah. So if you remove this E from here, it will become GGS EAY. So do you understand conditional parts, if parts, and else part? So it is easy. Just, we just did two things. The first one was put this one half in here, and after that, if store first letter E here, and append the I. All right, that's it. So we just set this one and this one. Do it like that. In the other way, we said if it is not like that, uh, do another thing. If first letter is vowel, we do it. But in this case, the first one works, right? If letter is, for example, A, not sorry, Y, not A or E, then it will become append first letter. It will add this one, and after that append I and remove first letter because first letter will be um, not vowel. I hope you understand. This is another method that we use in conditionals to just check if it is vowel or not. Okay? Iteration algorithms. So, algorithms often use repetition to execute steps in a certain number of times or until a certain condition is met. So, we can add iteration to previous algorithm to translate the complete press. So, phrase. So that peanut butter and jelly. So becomes anot pie but other utter like boy and yai eli jai. So it is a little long. It is three, by the way, three words. You can think like that. Three part. So how it works? Peanut, butter, and jelly. End of each of them we have pay. Can you see that? Half pay, half bay, half j. Like that. So what we are doing in here, and first letters already removing end of it, and we are applying for all of them, right? Store list of words, store list of words. Okay, we have E, sorry, we have P, B, and G, this one. So then it's saying for each word in words. Okay, now we're going into this part, anot, pay, utter pay, bay, and yai, yeah, yai, eli, this one, J, I think, yeah. So we sang append hyphen. All right, we append that one. And if first letter is vowel, do you think something vowel in here? No. Append the I. All right, in this case, nothing there like that. Because for loop checking each of this guys here and nothing there about it. Like, yeah. By the way, look here, sorry, not the other one. It's checking for each of the first letter of the sentences, sorry, words, and it's saying no, there is no vowel. So as we know, there is no vowel, and I can't add yai. This is if conditions in here, sorry, in here, and this is for loop part. Okay, this is for loop, and this is if conditionals in here, and this is else part of if conditionals. Yeah, it's saying otherwise append first ladder. Okay, as you see, P in here for this one, B for the butter in here, and the last one is jelly, and we adding here J. We added each of them first letter, right? Prefix letter. And we saying add A and remove first letter. And after that, we're removing this P, B, and this one. And it comes inot pay, other pay, and Ellie J. Like that. I hope you understand what I mean. So is it clear for you? I'm not sure, but it is something that we're using for the market organizing, okay? Important. I will show you an example, no worry about it, okay? By combining sequencing, selection, and iteration, we've successfully come up with an algorithm for Pig Latin translation. Pig Latin is really little crazy one for the example, but yeah, Khan Academy is mentioned like that. But I will give you more different examples Just be sure about it. You will understand. Sarah is writing research paper for literature class where the must cite cite I think many sources. She decided to make a tool to automate the citation process. Comes up with the following algorithm for studying a book. So split author name. So first, let's say we have words. We just splitting author name into first name and the last name. All right, sorry. Then without going like that, let's say we have something like that. Like I mean, maybe I can do it like this. Let's say this is John Verson, like that. Verse, John Verse. There is nothing like that. We just splitting in this way, okay? First, like that. Then combine last name, comma, with first name and period. Combine last name, comma, yeah, okay. This one. First name and period. Combine title with period and wrap in italic style. Okay, I can't do. I don't want to do it like that. Combine publisher, comma, year, published and period. Okay, we do same things for the others. Combine strings from steps 2 to 4. Combine strings from step 2 to 4. After using the algorithm successfully for a single book, she decided to extend it to generate citations for all of her books at once. All right, this is some example that I give you. You can just think all of them in the same way. What structure must be added to the original algorithm so that it can operate in multiple books? So, what do you think in this case? If we use iteration, will it works because it's talking about multiple books? Yeah, we have many more author name and first name and last names we need to go in it, right? And after that, we need to combine last name, comma, first name, and period. And we need to do also combine it title with period and wrap in italic style. Many more steps. Do you think it is iteration? I think so, because we can use also selection and the sequencing in iteration. I think like that. Do you think like that? Maybe I tricking you. Just think about it. Just you can say, let's say, for author in authors, like that, for author of authors, then we can just go into author and we can just split names and the other things. For example, if you have data, list data, right? Or even the other one. So just think about it. Is it this one or the others? Sequencing or selection or none of them? So what do you think about it? ABBA Speak is a game invented by school children discuss to what you're speaking, all right? When speaking, they transform each word following this algorithm. For each letter in word, if letter is vowel, add B after, all right? Add that letter after B. Uh-huh. Add B after, add that letter after B. So what will happen in this case? Following algorithm, how would they transform word avocado? Let's say we have avocado, all right? And after avocado, we just want to make some differentiation for each letter in word. If letter is vowel, in this case, A is vowel, this one is vowel, O is vowel, A is vowel, right? If letter is vowel, add B after. Okay. If it is A, B has to be next to it, right? In this example, it is true. In this example, too. And in this example, too. Because if it is A, or even if it is vowel, then put B after this. And add that letter after B. Add that letter after B. So, what it means? At same thing after B, right? After B at the first letter that we found it, right? And after that it becomes like that. And the second one we have V right in here. So is it vowel? No. Then add what? at B. Is there any B, do you think? Or it is correct one? What do you think? So just think about it. This is another step that you can talk about. So it's saying if letter is vowel, but in this case, V is not vowel, isn't it? If it is not vowel, we need to put B. Okay, let's check this example. We have A, B, okay. Then what we have? V again, O, B, like that. In here, we have B, A. After O, we have B, right? Okay. Then we have what? C in here, right? So, but in here, if you see, we have O. So in here, we already applied VO because look, V in here, and we already put B there. So VB, where is the VB? Can you see? No, can't see because we have O in here, and O is directly coming after that letter after B. So N in here. So you can say O. And after O, it is if it is like a vowel, we're adding B. As you see, we have B in here, right? And after B, at that letter after B, at that letter what? B. B here, and again A, right? Isn't it? Okay. It is so mixing. I know what you mean. So then we have C. So C is vowel now. So then we have what in here? We have A. Why we add A there? Because this one is the another one that we're adding there. If it is vowel, that we continue like that. But do you think this place is true then here? Which one is true? So let's look the last one. Last one is O, right? If it is vowel, then we have B next to O, and after that, add letter after B. Add that ladder after B. Add that ladder. Which ladder? First ladder, vowel one, right? It is A. So A is following each step in the same way. So do you think this one true or this one true? What do you think? I already explained it something in easier way, but maybe it can be difficult to understand. But just think, if the letter is vowel, this is vowel. Add B, and after that we adding B, and after that A is coming back. If letter is vowel, in this case V is not vowel, then what we're doing? Nothing. I mean, okay. So then we're going here. O, we have O. If it is vowel, O is vowel, and B coming there, and we're adding again A because we need to add A each time if it is vowel because we saying in here after B add the this one, right? So then we have here C, and all of them going in the same way. Do you think this one true? Or no, this one? I think last one. What do you think? Not tricking to you. The following algorithms computes the average height for a list of basketball player heights. Initialize a variable sum to 0 for each height in the list. Convert height from feet inches. Format the total inches. Add the height to sum. Return sum divided by the total number of heights. As you see, we already use here for each. When you use for each, as you know, this is iteration, right? So it is for loop. You can think directly like that, right? Or do you think this is selection or sequencing? Sequencing is already living in this code, pseudo code, but you can see selection is also there now. What do you think? Now maybe iteration plus sequencing. Just think about it. This one or none of about what? So think again about it. Think. You can think about it. I will give you more examples, no worry, after this class time, okay? So let's come to here. I mean, Okay, in JavaScript part, yes. Let's say we have a list of cars like that. And let's say this Mercedes and it is Ford, it is BMW like that. Okay. Now I'm coming here. We can say for, yeah, for X or member, we can say member of list of cars, right? Then comment it. We can say member dot push, or even we can use other things. Let's say I want to append there something, push there something. We can say add for the each of the member, like push there something else. Let's say 01. Okay. But we need one more thing. We can put if. So let's say if member, each of the member, yeah, we can think like that. If member is, sorry, not is, if member is vowel, that we can say vowel. So, but how we can represent that? If member equals or like that. Some words like we can, by the way, we can say also first letter or like a prefix, uh, like that. Sorry, let's come here, like that. Let's say equals a, yeah, like that. We can separate it. Let's do it like that. A O. Yeah, let's try something like that. Do some stuff. What? Member push 01. Else, it will not work for the first. I know. And I will explain you why, okay? Oh my god, just give me the conditional parts. Yeah. So else, do what? Else member dot push, push what? Let's say 10 10 10 like that. And this is something that I'm trying, okay? When you run that, what will happen? Push doesn't work. Why? Do you think we need to make them something like that? Let's say in here return member. What do you think? Do you think it works? No. It's all about push, right? Push doesn't work. What do you think? What if we add one thing directly there? Like this. Still same? What's going on in here? What do you think? Member, then put this one. Do you think maybe we need something different to explain that? Okay, let's say all something like that, and say var a like that, and just say return a or all. Let's say a. Does it work? Nothing. Where is a? Where is all? It doesn't work, right? What do you think about it? Why it doesn't work? By the way, we didn't put anything in here. Just put some 111 like that. It will say again same thing. Push. It doesn't work. So delete this one directly from here, and just put if in here like that, and just return something after if. What will happen in this case? By the way, just delete this O2. Yeah, what will happen? Nothing. Let's say console.log, yeah, a, put there and see what will happen. Okay, because nothing in here starting with the vowel, right? What if we do it like that? A, Aercedes, or even Earcedes, Eort, and OV me like that. Member dot push. So what is the problem in here? What do you think about push method? Why it not representing anything? Push what? Okay, let me do one more things. Let's say what p, let's say, and just give there some words. I mean, like zero, something like that, and put p into p and run it. Still same. Push is doesn't work. It's not a function. It's saying it's not a function. All right, I want to show you an amazing thing. Just come in ChatGPT and push like that and see what will happen. It seems like push function at the value zero and an array, but it works like what? Like that, right? Member. Aha. So we need to do first one thing. We can say member var member like that, right? Sorry, come here back. We can say member, the first characters of the member. It's already choosing that. What do you think? What do you think if you directly take it and put it in here? What will give you the result? Look, it will say what is wrong in your code. For off loop, then you are checking with the member. So it's saying check it like that, right? But why we use three times this member? I just want to give you an amazing point that we already did something like that. Are you remember? As I did in here. Where is that? Right here. Go back to the here. Yeah, like that one, right? And after that, we pushed in it. So let's go to the back here. And we did same thing in here. And we just tried to make it a console dot log that a. But one thing that we did in here, remember the first element or first one is equals a or member zero, like first element is equals e or blah blah blah, right? So now let's take this one and come back to there and we use of. No forget, if you use here in, it will count numbers, but when you use of, it will count elements. So let's put it in here and run that. Push. Still problem. Why push problem? What do you think? Why it doesn't work in here? So what if you say append? What will happen? No, we don't have anything like append, right? What can we use? Alternatively, let's come here and just say, what is the alternative of push method in JavaScript? Look what will happen. Concat. This is another way. List of cars. Then you're saying concat with the P. Okay, then it gives you this one. This is not mindly. We want to apply for here, right? So push, let's say push doesn't work. Why? Do you think it is about editor or really we doing something wrong? Maybe it's about this program is? Huh? What do you think? This is another step that it wrote right now, right? We use here concat. Okay, let's go back to the there and copy paste if it works. By the way, as you see, we already fixed things. Aha! It works. EORT, and we added this one. And OMV, we added this one, right? How we did? member dot concat with p. As we know, the member is this one, right? And after that, we just saying concat with what? Concat with this one, like like this, right? But what? Why it doesn't work for the first step in here with it with the push? Why it doesn't work? So should we say only concat like that? And how it works? Uh-huh. It gives same solution. So, as we can say, this is about editor, right? If you use in VS Code or in other platforms, you'll see the result. By the way, you can say like that, or even you can use the another method. So to represent the or, in here we did like remember the first one, remember the second one, or blah blah blah, something like that, right? But why we did three times? So it's already zero all of them. What about uh, like that? Why we have three times? But let's say in ChatGPT that we have three elements, but we don't want to write it three times, right? So let's go back to there and say, look, we have three times query with or, so it is a lot. Can you decrease that? That's that. Let's do it like that. Uh-huh. Yes. So what we have now, we used length, but still this is same. It's still tracking with each of them, right? So let's say why it were it reading it's in reading three times. Let's say like that. Let's see what will happen. Mm-hmm. Uh-huh. It applied different method, right? It is sequential algorithm that we're using right now in here, right? But in here we have iteration, and in here we have what? After sequential, or you remember that we use three topic selection, sequencing. This one is selection. In here we have selection. In here we have sequencing, right? This one is sequencing. This one is iteration, and this one is sequential. Sorry, selection. As you see, now it's decreased, but with includes member zero. Now we did like that, and we just tag them into that one, and we just go in it. And after that, we concat with the others. So what I'm talking about, if you want, you can just reduce them in some way that you can apply. Even you can say if something like that, do these things, or even you can just do it like this, and you can come down again and you can say another if, and you can open that, and you can just close it in some way. All right, let's come here again and put same thing there. This one, yeah, go in it and close that and run. Do you think it works? What do you think about it? Run that, nothing, right? But why it doesn't work? We just saying if do something. Aha. So we need to say each time we need to come here and we need to put this codes to run this, right? So like that. Let's do it like that and run this. Uh-huh, it works. What about this place? It will be so cheapy job, right? So it is so tiring job. If you do that, it will give another one. And if you do same things in here, it will give last one. I mean, all of them will work in the same way. So just tag this one in here and do same stuff for each of them and everything will work amazingly. But this is lazy job. We can do it in that way easier than the other way, right? Just use this operator, guys, like this one, operator. It will help you directly to write your codes. That's it. I hope you understand what I'm talking about. So with it, and you know what it is, right? You can work on it. Let's do it with yourself and see what will happen. Thank you so much for the joining. The next one will be expression and algorithm. Just you need to know that before closing. Again, I'm saying, look, guys, this is something sequential. Let's write there. Sequential algorithms. Algorithm. So what it means that you're reading code like that. Okay, there is no for loop, there is no if conditionals. But when you create a for loop or even while loop, this one will be iteration algorithms, right? Cool. So and this one, this is something that we counting things in it, or we iterating things that we using iteration algorithms for each of the items. And this one is our last one. We can say, uh-huh, we can say it is what? It is what? Selection, right? Selection algorithms. So it is we just choosing. Selection mean what? If something like that, just choose it and apply as you see in here in application, right? Else do another thing, but again, apply things there. That's it. I hope you understand. Thank you so much. Just you need to know in this class three things: sequential algorithm that you see in here, and iteration algorithms like for loop, while loop that you opening this for the countings or for make it order, and the selection algorithms is the if conditionals or even else conditionals that you're using in JavaScript. Also, we have switch and the others, uh, try except and the others. They are also in that way. Okay, that's it. Thank you so much for joining. I hope you enjoyed during the class. See you in the expression and algorithm class. So this is part of building algorithms. Yeah, let's go back to there. I don't want to make mistakes. Expression and algorithm. Sorry. Let's come here. Practice questions. Yeah, expression and algorithms. So let's go back to the here. Evaluating algorithms will be our second topic. So we already completed building. No. We just completed the first part of the building algorithms. We let's see you later into the second part. Okay, first part done. Building algorithms, but not all. So we completed uh, expression and algorithm. No, not this part and this part. Only building algorithms part. See you into evaluating algorithms part. Okay, after second part done. So first we will continue with the expression and algorithm. After all done, we continue with the what, with the evaluating algorithms. Still we are in here. See you in part two. Part 2. So the part 2 will be expression algorithm. Yeah, that's it. I'm just taking my note here. Algorithm. Thank you for joining. See you there, guys. Sorry again if it is longer.